Demand option. The first demand option is influencing demand. Use advertising or promotion to increase demand in low periods. Second is back ordering during high demand period. Requires customer to wait for an order without loss of goodwill or the order. The third one is counter-seasonal product and service mixing. Develop a product mix of counter-seasonal items. Capacity option. The first capacity option is changing inventory levels. Increase inventory in low demand periods to meet high demand in the future. The second one is varying workforce size by hiring or layoffs. Training and separation costs by hiring and laying off workers. Laying off workers may lower morale and productivity. The third one is varying production rates through overtime or idle time. Although constant workforce may be difficult to meet large increases in demand. The fourth one is using part-time workers, useful for filling unskilled or low-skilled positions, especially in services. Determinants of effective capacity. The first one is forecast demand accurately. The second one is match technology increments and sales volume. The third one is find the optimum operating size. And last but not least, bid for change as changes will occur in processes, product volume, and product mix.
Disaggregation, the aggregate planning. It is the process of breaking an aggregate plan into greater detail. This aggregation results in a master production schedule which provides input to material requirement planning (MRP) systems. The master production schedule addresses the purchasing or production of major parts or components. It is not a sales forecast. Detailed work schedules for people priority scheduling for product result as the final step of the production planning system. Second techniques of aggregate planning is mathematical approach. Mathematical approach is a way of solving for the optimal solution to an aggregate planning problem. It is not a try and error approach like graphing, but rather produce an optimal plan for minimizing costs. It is flexible in that it can specify regular and overtime production in each time period, the number of units to be subcontracted, extra shifts, and the inventory carryover from period to period. It does not work when non-linear or negative factors are introduced. When the other factors are introduced, such as hiring and layoff, the more general method of linear programming must be used. Graphical methods. Graphical methods is aggregate planning techniques that work with a few variables at a time to allow planners to compare projected demand with existing capacity. It is trial and error approach that do not guarantee an optimal production plan, but they require only limited computation. It can be performed by clerical staff. There are 5 steps in the graphical method. First, determine the demand in each period. Second, determine capacity for regular time, overtime, and subcontracting each period. Third, find labor costs, hiring and layoff costs, and inventory holding costs. Fourth, consider company policy that may apply to the workers or to stock levels. 5. Develop alternative plans and examine their total cost.
A master production schedule is a plan for individual commodities to be produced in each time period, such as production, staffing, inventory. It is usually linked to manufacturing, where the plans indicates when and how much of each product will be demanded. This plan quantifies significant process part and other resources in order to optimize productions, to identify bottlenecks, and to anticipate needs and complete goods. Since an MPS drives much of factory activity, its accuracy and availability dramatically affects profitability. Typically, MPS are created by software with user tweaking. The MPS translates the customer demand into a build plan using planned orders in a true component scheduling environments. User MPS have avoided shortage, costly expediting last-minute scheduling, and efficient allocation of resources. Working with MPS allow businesses to consolidate plans, parts, produce master schedule, and forecast for any level bill of materials. What is Material Requirement Planning (MRP)? One of the first software-based integrated information systems designed to improve productivity for businesses. A Material Requirement Planning (MRP) information system is a sales forecast-based system used to schedule raw material deliveries and quantities, given assumptions of machines and labor unit required to fulfill a sale forecast. MRP was the earliest of the integrated information system dealing with improvement in productions for businesses with the use of computers and software technology to provide meaningful data to managers. With the advance of such a system, production efficiency could be greatly improved as the analysis of data and the technology to capture it became a more sophisticated, more comprehensive system were developed to integrate MRP with other aspects of the manufacturing process.
ERP or Enterprise Resource Planning is a business process management software that allows an organization to use a system of integrated application to manage the business and automate many back-office functions related to the technology, services, and human resource. ERP software typically integrates all facets of an operation including product planning, development, manufacturing, sales, and marketing in a single database application and user interface. ERP software is considered to be a type of enterprise applications. That is a software designed to be used by larger businesses and often requires dedicated team to customize and analyze the data to handle upgrades and deployments. In contrast, small business ERP applications are lightweight business management software solution. It's often to customize for the specific business industry or vertical.